and one inflection point. So I see one root. What's another root that this has? The plus, because what are those called? Conjugates. Okay, it has another one. When somehow along the line, I'm missing one more. Technically the same as last night. We're going to do a synthetic division. We're going to divide. Then we're going to divide by this root. And we should come up with the last root. We're going to do this two ways. We're going to do it the synthetic division way first. So we're going to take out your coefficients. 3, 2, 1, 0. And we're going to divide by that x value. It looks messy, but it all works out, because you never see these radicals in your quadratics anyway, so you know somewhere along the line it has to work out. So we're going to start your synthetic division. So you're going to take this, do the same thing you do, multiply it by 1, it goes over here. We're going to add down. So if I add -1 plus 2, just the real part of it, what do I get? 1. If it helps, I usually keep mine in parentheses so that it doesn't like make one whole big messy line. Now you're going to take this guy times this. Now, when you do this, give yourself a little space on the side, work it out. So I've got 2 minus radical 5 times 1 minus radical 5. So this is going to give me 2 minus 2 radical 5 minus 1 radical 5 minus 3 radical 5. Whoops. And my last one, a negative times a negative is a positive 5. Now combine those like terms. What do you get? What's 3 plus, what's 2 plus 5? 7. Okay, add down. You're looking at the -13 and the 7. So what do we get? Okay, multiply again. See what you come up with. Multiply 2 minus radical 5 times -6 minus 3 radical 5. What is this going to come out to be? What's my remainder going to come out to be? My remainder has to come out to be what? 0. So let me just give you a hint. Look up here 1 second. If when I subtract this, my remainder has to be a 0. What is that number you think it's going to be? 3. So since it doesn't have radicals, I might want to just try to put this in my calculator. If I did everything right, that's going to come out to say 3. You can cheat a little. You can cheat a little in there. We know that's got to work out because my remainder has to be 0. I have 3 roots, and I do know what one of my other roots is. So do that part on your calculator if you expect that to come out to be a whole number. So that does come out to be 3. So far, we're good. We did one root, and our remainder was 0. Remainder theorem says, good, I got a root. I'm going to do it again. I'm going to take my other root. It's a little messy. Give yourself a little extra space when you do these because, God bless you, they kind of run into each other.
Are we doing it from the one we just did?
From the one we just did.
Why don't we just do it from the one we just did?
Because from the one you just did, then you're going to have to take this one out again. So if we keep taking out your roots, aren't we breaking this down? Now I should have x squared. So now I'm going to take another root out of it, and I'll be left with an x1. God bless you. I want to keep taking my roots out of this. I don't want to stop here and make another quadratic or make another polynomial because it won't make any sense to me. So now, bring down the 1. Multiply by 2 plus radical 5. This one gets a lot easier. What happens to my radical 5s? They cancel. What is 1 plus 2? 3. Multiply 3 times 2 plus radical 5. I get 6 plus 3 radical 5. And don't I have to come out to be a 0? Yep, because we know that was a root. Your remainder theorem says if it's a factor, your remainder is 0. And yep, we knew that was a factor. Now, we did 2 of them. We started with x3. We went down to x2. So now we're down to x1. This says x plus 3. There's my last factor. If I set this equal to 0, what's my other root? Negative 3. So now I know all my roots. So this has 3 roots altogether. Yes.
Why did you do x equals 2 plus square root of 5?
Because that's another root that we know of.
Okay.
That's a root that we know of. I give you one root. You have to keep synthetically dividing until you find all the roots. Okay? Now, that's your synthetic division way. Another way is this. Here's one root. Can we come back to a quadratic on this? What's the sum of these guys? If I add those together, remember you can add them in your calculator. If I add them together, what's my sum? 4. Let A equal 1. So what's B? Okay, now do the product. They're perfect squares. 4 minus 5. Do it in your calc. So what's my product? Just multiply them. Put it in your calculator. So the first term's 4, the second term's minus 5. Get a negative 1. Put this in your calculator. These are your perfect squares. You should multiply your first terms, your last terms. Your middle terms cancel out. Okay? So what is C? So here's my quadratic. X squared minus 4x minus 1. So I could take my original polynomial. This contains 2 known roots in here. And I can divide by this guy. Right? Can I? Wouldn't that make sense? This quadratic contains 2 roots. If I divide those 2 roots out of there, shouldn't I get the last root? So let's see what happens when we divide this. Yeah, the synthetic division part is only bad on the first round. By the second round, it all works out. So, give me the coefficients. 1, negative 1, negative 13, negative 3. This leading coefficient is 1. We're going to do a double divide. So it's going to be 4. You've got to pull them out the opposite way. Work with me here. Pull down to 1. 4 times 1 is 4. 1 times 1 to the right, 1. Add this guy down. 3. 4 times 3 is 12. 3 times 1 is 3. Whoops. 3. Add down. What does this guy come out to be? 0. What does this guy come out to be? 0. X plus 3 is my last factor. If I combine 2 of my roots that I know of, because a perfect square pair makes my conjugate pairs make a perfect square, I know what the other root is. I can just divide that quadratic out of there and find out my last root. Technically, you can divide synthetically. The only bad part is the very first part. By the time you reach the second part, you pretty much have 3. I should get 3 roots. So I need a starting place. So put this in your calculator and find me 1 root. I just want 1. How do I recognize a root? When I look at my calculator, how do I recognize a root? When y equals 0. All I want is 1 of them. And yeah, I know sometimes they're all in your calculator, but you still can only come out with 1 of them because we have to find this algebraically. There's no guess and check. There's no finding them on my table and say, here's my roots. I need to synthetically divide them all out. So you found the 2, 0?
Yeah.
So your root is 2. If we start dividing by 2, then we should get down to a quadratic. And can't we factor a quadratic when the exponent is 2?
Yes.
All right, so let's take out these coefficients. 10, negative 15, negative 16, 12. We're going to factor out a root of 2. What should my remainder be? 0, because we know that's a known root, right? So that's a good way to start. So, go down to 10. 2 times 10 is 20. Add it down. 5. 2 times 5 is 10. Add it down. 2 times negative 6. Ah, that was good. I knew that was going to be a root. Now, you have 2 choices. Do you have another 0 in there? Is there another 0 besides the 2? If you look at your table, was there another y 0?
Well, it's not an exact number. But it's not an exact number.
No, it's not an exact number. So what's it going to be? It's going to be an irrational root. So we should get a conjugate pair. So that means, let's take this out. If we did x divided by x minus 2, we should now be x squared, x1, x0. This is a factor. Okay, I'm going to set this guy equal to 0. And I'm going to factor it. But you didn't see another perfect square factor in there. So you have 2 choices. You can complete the square, or you can use the quadratic equation. Because they're irrational roots, right? They're still 3, they're still real. I don't have a picture of what your graph looked like, but it should cross the x-axis 3 times. 1 you can see, 2 you can't. So you have a choice. What I tend to do is, if my middle number is not even, I tend to use the quadratic equation. This way you don't end up with a fraction when you do your synthetic division. But you can do it either way. Synthetic division, don't forget to pair these up, factor out the 10. So let's use your quadratic. Some roots just don't work out nicely. So we know that A is 10, B is 5, and C is negative 6. And if you put that part in your calculator, you get 265. Can we reduce 265 at all to a perfect square? No. And do not cross out the 5 and the 20, because these are 2 terms up here. If you wanted to, you could separate them and make them negative 1 over 4, plus or minus radical 265 over 20, but I wouldn't waste my time doing that, because nothing cancels out. So I would leave it like this. Do not cross out the negative 5 and the 20. So those are 2 roots. Now, you have your calculator handy? Let's see if that is a 0. Watch how nice this works. Go to second calc, do number 1 value. When you get the x, I want you to put in, and you got to watch your parentheses, 5 plus 2 do 65, close that parentheses, divide by 20. Put that exact root in there, and what should your y say? 0. Does it say 0? Yeah, isn't that a good way to check your roots? Because this looks kind of crazy, like who has a root like that? So I want to go in my calculator and I want to check and make sure that that's my root. So we take this polynomial and we say it has 2 and -5 plus or minus 65 over 20. These are my zeros. Those are my zeros. Not all of these work out picture perfect. You will find some when you take a polynomial, especially when it has maybe 4 or 5 roots. You'll have 4.
Wait, I think
One's a double root. What?
I think you just hit record.
I know, I didn't record this before.
Um,
Okay, so what we did, we took, just guys, look, we had an exponent of 4. That means if you want to get down to a quadratic so you can factor it, we got to find your 2 roots. We did. Doesn't matter what order you divide. What you know is that this guy has to be a 0 because you know those are your roots. If they don't turn out to be 0, something happens. Divide by the first one. Just keep it rolling. Divide by the second one. Get a quadratic, and then bring your quadratic and factor it. If it's not factorable, either use complete the square or use the quadratic formula. But you got to get it down to a quadratic. Now, if they would have given us one more root, we could have divided this out and then ended up with a y to the 1 and found our last root ourselves. And I know sometimes you're going to see them all in your calculator, but you still have to go synthetic division. You still have to do synthetic division.